Question number 2. We have a square coil of 50 turns. So this is N. Has sides of length 5 centimeters. So that would basically give us the area lah later. Yeah, if we need it lah. So it is placed in a uniform magnetic field of 20 millitesla. So this is B, so that the field is perpendicular to the plane of the coil. Calculate the average EMF induced in the coil. Induced EMF when it is pulled out from the magnetic field in 0.1 second. So for the initial flux, we know that the angle will be equal to 0 lah. Okay. Because kita tahu when the plane of the coil is perpendicular to the magnetic field, the vector A will be parallel to the magnetic field. Okay, so this is our coil, and we know that the vector A will always be perpendicular to the surface. So this is A, this is B. So the value of theta will then equal to 0 degree. Okay, so how do you find the induced EMF is basically using this formula written here, dphi over dt. So the rate of change of magnetic flux lah. Okay, so sekarang ni what is the rate of change of magnetic flux? It is basically just the final magnetic flux minus the initial magnetic flux divided by the time. Okay, so that is the formula sekarang ni. Okay, so what is the formula of phi? We know that phi is gonna be equal to B A cos theta. Okay, so let's see what is changing. Okay, so dia cakap so sekarang ni okay, so we have our final velocity, so the final magnetic flux here will be equal to 0 lah. Okay, kenapa equal to 0? Sebab when it is pulled out of the magnetic field, our value of B here will be equal to 0 lah. So automatically our final magnetic flux should be 0. Okay, so when it is pulled out from the magnetic field, so they're pulled out of the magnetic field, bukannya dia keep on going inside and then going out. Dia cakap sekarang ni dia sudah pulled out from the magnetic field, so theta sudah nilai B di situ, so that's why they equal to 0 di sini. Okay, so untuk initial pula it is BA cos theta as well, but the initial magnetic field is already given in the question, which is 20 milli. Okay, so 20 milli, and then area is L times L, so that is basically 0.05 square lah kan. Lepas tu cos theta, so cosine dengan 0 degree. Kenapa 0 degree? Sebab we know that the magnetic field is perpendicular to the plane of the coil. Okay, so kita dapat di sini equal to 5 times 10 to the power of negative 5 Weber. Okay, so dari sini saya akan substitute into this equation here. So negative 50, and then final is 0 minus 5 times 10 negative 5 divided by the time, which is 0.1 seconds, and then we will have the value to be equal to 0.025 volt. Okay, so this is the average induced EMF lah for question number 2. Okay, so this is basically the solution for question number 2.